The question says, which of the following standard conditions? Now, when we're talking about standard conditions, we're trying to talk about probably standard temperature and standard pressure. Okay, can you hear me?
Sure, sir.
Okay, so we're talking about standard temperature and standard pressure. And standard pressure is 1 atm. Okay, so that one is correct. Standard temperature, we can now talk about, is it is it 0 or 25 degrees Celsius? Talking about standard temperature. Standard temperature and pressure means STP. When they mention STP, so 0 degree Celsius, which is 273 Kelvin. Take note, 273 Kelvin. That is standard temperature. And standard pressure is 1 atm. So on the other hand, if we value uh, delta G, which is between delta G and delta H, energy changes. The standard ambient temperature or and pressure, which is SATP conditions, are commonly used to report data in chemistry. And the SATP is 25 degrees. So if you say 25 degree plus 273, you get 298. So that means the first one, because we would have said the first one is not correct because standard temperature is supposed to be 293 and not 298. But 298 is used in reporting data. So definitely because of probably room temperature at 25 degrees C. So this is also correct. So if this is correct, the second one is correct. Let's go to the third one to see whether it is also correct. Concentration of solution must be 1 gram per mole. That is a standard concentration. So what about the last option? The last option is not correct because it said delta H at 298 Kelvin
Kelvin
is
is
the
the activation.
activation energy. Activation energy varies, okay, based on which reaction you are referring to. Is that clear?
Yes.
Activation energy varies. So this is the one that will say it's
Okay.
not correct. Is that clear now? Is that clear now?
Yes, sir.
So let's go to the next question, which is for Moses. So let's see what we have there. Hold on. Trying to. Okay. So the question is zero point 0.2. It says if 5.0 cm cube of zero point 0.2 mole per dm cube of Na2CO3 was diluted to 250 cm cube solution, what will be the concentration of the resulting solution? That is the final concentration. So we have molarity 1 times volume 1 equal to molarity 2 times volume 2. So we're looking for molarity 2, which is M2. That will be M1V1 over V2, which is 5 times zero point 0.2 all over 250. And this is like, say, 5 times 2, yeah, then 2500. Then this is 10 over 2500. 1 0 cancel 1 0. Then we have 1 over 250. 250 in 1, that's 0. In 10, that's 0. In 100, that's 0. Then in 1,000, that is 4 mole per diem. So that's why the first option is going to be correct. So I'm going to bring the next question right now for Mercy as stated. Just in this question, we're talking about the initial volume and pressure of a given mass of gas, then final volume and the pressure of the same mass of gas. So we have the formula P1 V1 equal to P2 V2. So we have a pressure 1 has been given as 3P, while volume 1 is still V. But volume 2 increased to 2V, while pressure 2 is what we're looking for. So P1 is 3P. If we say, let's say, I want to change that color. So 3P times V1, which is V, equal to P2 that I'm looking for
P2
times
2V.
V2, which is 2V. So here now I can say P2 equals to 3PV over 2V. So this will cancel this one. So P2 equals to 3 over 2P, not 32P. Okay? Is that clear?
Yes, sir.
Okay. So I'll bring the next question for Ty. Let's see. It says, what volume of oxygen at STP is required to burn completely 7.5 dm cube of methane according to the following equation? So what we are to look for or to look out for in the equation is the number of moles required. Consider that 1 mole of CH4, it's only 1 mole there, react with 2 moles of oxygen. That is 1 and 2. So if you're talking about 7.5 moles of, 7.5 moles per dm cube of methane, that will be times 2 because 1 times 2 is 2. So 7.5 per dm cube of, you know,
Time just finish. Very much.
mole per dm cube
Still
of CH4 will be 7.5 times 2 mole, you know, of oxygen. So that will be 15 dm cube. Is that clear? That is this
Yeah.
volume, even if it's not more. So dm cube. So that is how you arrive at the answer C that you guessed. So it's so dm cube. So the next question is for who?
Sarah.
Okay. Is it Sarah? Okay, yeah, Sarah. That's first person. Hold on. So the question says, when 250 cm cube of a saturated solution of copper sulfate at 30 degrees C was evaporated to dryness, 5.0 gram of the salt was obtained. What is the solubility of the salt at 30 degrees C? Given that the molar mass of copper sulfate is 160 degrees. Okay, what we need to know is that the solubility of salt will be number of moles of the salt over volume of the solution. So we're given, please listen, please listen. We're given 5 grams and the molar mass is 160. So this is also going to be equal to the number of moles over the volume of the solution. So we have, what is 5 divided by 160?
That's 0.03.
0.03125.
Yeah. So
0.03125. If the figures are not too long, it is advisable to use all because it might affect your answer.
0.03.
Hold on. So now the solubility of the salt, given that the volume is 250, so
It's still
volume
so.
equals to 250 cm cube, which in a dm cube is going to be 0.25 dm cube. So this is the number of moles, and this is the volume. So we have the solubility now will be number of moles, which is 0.03125 divided by the volume, which is 0.25. So divide this and see what your answer should be.
So 0.125.
0.125. So to get the number of moles, you divide the mass by the molar mass, okay? Exactly.
Yes,
Yes.
sir.
So the next question is for Moses. So I'm going to bring it right there. So, question says the bond between ammonia and hydrogen ion in ammonium ion is dash. And you were right by saying this is dative bonding. In electrovalent bonding, there is transfer of electron. Good. Now, in the ammonium ion would have covalent bonds because both. Are you listening? Are you listening? Okay, so the ammonium ion would have, which is NH plus NH4 plus, will have covalent bonds because both nitrogen and hydrogens are non-metals. So of this covalent bond, one of them will be considered a dative covalent bond, which is a covalent bond where uh, they both share the electrons that come from the same atom. And that is why we go for dative bond. Is that clear? Is that clear?
Yes, sir.
So I'm gonna bring the next question. It says, which of the following oxide has a giant covalent structure? I think the first thing we need to talk about is what giant covalent structure is. It's a giant covalent structure is where large number of atoms are joined by covalent bonds. A giant covalent structure involves a lot of covalent bonds present between several atoms in a regular pattern, forming a giant lattice. As lots of covalent bonds are present in the compound, then the structure is extremely strong. Any element that is tetravalent tetra, tetravalent can be considered to form giant structures. And they can combine with several. If you consider carbon, carbon is not A. If you consider carbon, carbon is tetravalent because it's 2 comma 4. Okay, so it's can form. So then, if you consider silicon, silicon is what number on the atomic on the periodic table?
Um, 14.
14. So that is 284. Okay, is that clear? So which option do you think we should go for?
Silicon.
Okay, silicon dioxide is an example of substance with giant covalent structure. It contains many silicon and oxygen atoms. All the atoms in its structure are linked to each other by strong covalent bonds. So the atoms are joined to each other in a regular arrangement, forming a giant covalent structure. So uh, the answer is SiO2. That is silicon dioxide. Okay, the next question is for who? Okay. Question says which of the following hydroxides is not readily soluble in water? Soluble mean that will not readily dissolve in water or mix with water or something. So now the hydroxides of sodium, potassium, and ammonium are very soluble in water. The hydroxides of calcium and barium are moderately soluble. So it won't be readily soluble. So the correct option is B.
This is French.
The correct option to that is B. Is that clear?
Yes.
So let me bring the next question, which is for what do you go for? Which one do you go for?
Either B.
B. Okay, either B or which one?
Either B or A,
Yeah.
because
Okay.
D, of course, solubility of a solid would definitely affect
Crystallization. So you are right
that
on that.
solution. It's either B or A.
Okay. Now, what we need to know is that crystallization is based on the principle of solubility. Yeah, just like you mentioned. So compounds which are solutes tend to be more soluble in hot liquid, which are the solvent, than they are in cold liquid. So if a saturated hot solution is allowed to cool, the solute is no longer soluble in the solvent and form crystals of pure compound. So the correct option there will be C, okay? The crystallization will be efficient in separating out salt whose solubility increases considerably with temperature. So can we move on now?
So wait, sorry.
Okay.
Sorry, can scroll.
Okay, now the next one is for Moses. So Moses, how many moles of H2SO4 are there in 50 cm cube of 0.108 mole per dm cube of the solution?
Huh?
So should we look at this together?
Okay.
No, so I've not finished solving.
Okay.
Hey, coming down. Oh,
Mm-hmm. Are you almost there?
sure, sir. Um, sir,
Yeah.
I got C times 10 to the power minus 2.
Okay, 5.4 times 10 to the power minus 2. Okay, let's look at it. It says number of moles. Number of moles. Moles equal the molar concentration times volume over 1000. So we have 0.108 times 50 divided by 1000. So multiply this and tell me what you have.
That's me.
0.108 times 50, that's 5.4 divided by 1000, that is 0.0054. 0.0054, and that will be 5.4 times 10 raised to power what? 1, 2, 3, minus 3.
Oh, minus 3.
Okay, and that is where we'll be rounding up for today. But do you mind if I show you just one song before we go?
Ah, sir, yes, sir.
Okay, let's see how it goes.